Today, in this tutorial I will discuss Graham's law of diffusion. Let's start with introduction. Graham's law of diffusion was formulated by Scottish physical chemist Thomas Graham in 1848. Graham found experimentally that the rate of diffusion of a gas is inversely proportional to the square root of the molar mass of its particles. Statement of Graham's law of diffusion. Graham's law of diffusion states that under the similar condition of temperature and pressure, rate of diffusion is inversely proportional to the square root of its density. That is, rate of diffusion of gas R is inversely proportional to the square root of its density d, where R is rate of diffusion of gas and d is the density of gas. Let R1 and R2 be the rate of diffusion of the gases having density d1 and d2. So, rate of diffusion of gas R1 is inversely proportional to the square root of its density d1 and rate of diffusion of gas R2 is inversely proportional to the square root of its density d2. Dividing equation 1 by 2 we get R1 by R2 is equal to root under d2 by d1. We all know that the molecular mass m is twice the vapor density, d. So we can say d1 is equal to m1 by 2 and d2 is equal to m2 by 2. Now, putting the values of d1 and d2 in equation 3 we get R1 by R2 is equal to root under d2 by d1, is equal to root under m2 by 2 by m1 by 2 is equal to root under m2 by m1. Again, we know that the rate of diffusion is equal to volume of gas diffused by time taken. Hence, we can say R is equal to volume V by time t, so R1 is equal to V1 by T1 and R2 is equal to V2 by T2. Putting the value of R1 and R2 in equation 4 we get R1 by R2 is equal to V1 by T1 by V2 by T2 is equal to root under D2 by D1, is equal to root under M2 by M1. If equal volume of gases are diffused then V1 is equal to V2, so equation 5 becomes R1 by R2 is equal to T2 by T1 is equal to root under D2 by D1, is equal to root under M2 by M1. This is the required equation of Graham's law of diffusion. Application of Graham's law of diffusion. It is used to measure the molecular mass of gas. It is used to determine the vapor density of the gas. It is used to separate isotopes. It is used to separate the gases mixture. It is used to measure the rate of diffusion.